Okay, hi everyone. So welcome to H2 Math, and we are in chapter 1 standard curves, and this video we are going to look into the different questions for test yourself. Okay, so for the very first test yourself, so this one is to determine whether each of the following statement is true or false. Okay, so whenever a statement, whether is it true or false, we have to like explain why or give the correct statement and so on, right? So now usually when we want to prove that something is true, we need to really prove it. We really need to sit down and do the math or explain in words, that kind of thing. Now if it is false, okay, so if it is true, okay, usually what the mathematicians do or what the logic people do is that we will need to prove lah. Okay, prove the prove with working, something like this. Okay, or proof with working or explanation. Okay, so then if it is false, okay, if it is false, then what we will need to do is we'll just need to give a counter example or a false example. Okay, so for this question over here, if you look at test yourself 1, okay, now the first question, x plus y modulus is equals to modulus x plus modulus y. So is this true or false? So over here I've already outlined that the answer is false. So if you want to prove that something is false, I'm going to give a counter example. So example would be the left hand side. Okay, so the left hand side, let's say if I were to choose two numbers, for example, if x is negative 1 and y is 2, okay, so this one, right, when you do the module, when you add together, this is modulus 1 and modulus 1 is equals to 1. Okay, now but okay, then we have to look at the right hand side. So this one, right, we are looking at the left hand side first. Okay, now then we want to see whether is the right hand side correct or not. Okay, so for the right hand side we have a modulus of negative 1 plus modulus of 2. Okay, so for this one over here, modulus of negative 1 is positive 1. Modulus of 2 is just 2. This one is equals to 3. So you see that the left hand side is not equals to right hand side. So this is why the answer is false. Okay, now for question 2 is going to be a bit different over here because, right, it is a bit hard to show whether is it true or false based on the understanding that we had last time. Okay, so what we're going to do over here is we're going to look into what does this mean. Okay, so what does this mean is if we want to unpack this math sentence, now so we have a mathematical statement over here, and then this arrow over here, and then the second mathematical sentence over here. So actually, right, it really means this. Okay, it really means this. So it means that now this part over here is the condition. Okay, so this would be the if part or the condition part. Okay, then over here, this arrow over here means implies, and then over here on the right hand side, this would be the results. Okay, so or the then. Okay, so it's an if then or condition results kind of thing. So if the left hand side is true, if the condition on the left is true, then the results on the right would be also true, that kind of thing. Okay, so how we are going to prove it, right, is that we're going to prove the left hand side statement first, and we're going to prove the right hand side statement. Okay, something like that, or we are going to give an example on the left and then it will lead to the example on the right, something like that. Okay, so for example, right, so this one is false. Okay, and I'll give an example. So I want to have a number on the left hand side that makes it true. For example, if I choose, okay, x to be negative 1, okay, or negative 2, up to you. Okay, choose x to be negative 1. So the left hand side, the condition part, okay, so the left hand side part, right, would be I have a modulus of negative 1, and I have a, okay, I will write this first. Okay, modulus of negative 1, and this is equals to 1, right? And then I have a 2 times negative 1 plus 1, and this is actually equals to negative 1. And we can see that this is indeed true. Okay, this is indeed true. Okay, so the left hand side, right, so for this part over here, okay, so this part over here is true. Okay, so this is what I'm trying to set up. Then I want to see that whether the right hand side is true or false. Okay, can so this is true. Okay, this one is true. Okay, but on the right hand side, let's see. I will start off with okay, over here, modulus of -1 square, right? So modulus of -1 square, -1 with modulus become 1, and 1 square is 1. Okay, then from the other side, I have a 2 times of -1 plus 1 square. So over here, 2 times of negative, oh, I don't think I see, okay. 2 times of -1 would be -1 plus 1 will become, 2 times of -1 will be -2 plus 1 become -1. And I have a -1 square. And this one over here, it becomes 1. Okay, but the thing is, right, it is not greater than, this one over here is not greater than the right hand side. Okay, it's actually in fact equal, so it's not greater than. Okay, so technically speaking, so this sentence is false, so it is false. So this whole sentence, so now this whole sentence become false. Okay, so this is how we tackle test yourself in page 6. Okay, so let's now look at test yourself in page 13 over here. Alright, and then we need to sketch the following ellipses. Alright, so this one, right, we will need to check and see whether there are really ellipses or not. Alright, so let's recall a few things. Okay, so the generic equation of a circle must be x squared plus y squared, and we can let it equal to an r square. Right, so this will be equals to the radius square, whereas for ellipse, this would be an x squared over a squared plus y squared over b squared equals to 1. Okay, so if you notice the form over here, right, the difference over here once again is, now I'm going to have x squared plus y squared, and the coefficient of x squared and y squared are the same. Now, and then over here, the x squared, the coefficient of x squared is a squared, 1 over a squared, and the coefficient of y squared is 1 over b squared. Right, so they have coefficients, and they may be different coefficients. And on the right hand side is actually 1. So if you compare and contrast, right, you should be able to recognize the difference between these two forms, right? And then you can tell me which one is a circle and which one is an ellipse. Okay, so without further ado, let us jump to A. Right, so for A, right, what form does it follow? Does it follow the circle or does it follow the ellipse? Right, so the answer is actually it follows the circle. Why? Because the coefficients of x squared and y squared are the same, and there is a plus over here in the middle. Right, so over here we can start with 9x squared plus 9y squared equals to 1. Right, and what do you do with this? I'm going to make the coefficient 1, so means I will need to divide throughout by 9. Okay, so I divide everything by 9, divide by 9, and divide by 9. Last but not least, I will have x squared plus y squared equals to r squared. Okay, r squared would be 1 over 3 squared. So that means the A, right, this is actually a circle with radius, okay, radius 1/3. Okay, and there we go. So here's the circle. Okay, so now also take note that because this is a x and y, right, so the center is actually 0, correct? So for standard curves, or more like the basic curves, the x and y, right, will give us the it will give us what? It will give us the shapes will be centered at the origin. Okay, so sorry. So over here, since the radius is 1/3, right? So I have 1/3 over here, 1/3 over here, negative 1/3 over here, okay, and negative 1/3 over here. Right, so this is how I sketch the first ellipse. Also, sorry, sketch the first circle, but the circle is an ellipse technically, so it's a special ellipse. Okay. Okay, for B, if you can notice above for B over here, right? So this one over here, we're looking at x squared plus y squared equals to 12. So this one, if you notice, the coefficients are still the same, right? It's still 1. In the middle, the operation is plus. So technically speaking, for part B, right, I have a x squared plus y squared is equals to 12. Now, what am I going to do is I'm going to find out the value of r. Okay, so if you don't mind me, I'm going to scoot up. Okay, so x squared plus y squared, right? Now, 12, right, is actually made of 4 times 3, correct? 4 times 3, right? So technically speaking, I can rewrite this as a square root. So 4 square root would be 2. Then 3 square root would be root 3. And this whole thing, I can write it as a square, right? So technically speaking, this would be a circle with radius 2 root 3. Okay, so this is how we express, okay, the r, which is normally not nice number, we can express it as a square root in exact forms. Okay, so so I have the same circle over here. So the radius is 2 root 3, right? So I'm going to put a 2 root 3, cannot see. Okay, I'm going to put a 2 root 3 over here, 2 root 3 over here, negative 2 root 3 over here, and a negative 2 root 3 over here, right, to mark out the space over here, right? So this would be the ellipse for part B, or the circle for part B. Okay, so now if you notice for part C, right, we have 4x squared, 9y squared, and 16. So you notice that the coefficient of x squared and y squared are already different. So over here, what we need to do is we need to make it such, because no, over here what we need to do is to recognize that it is actually not a circle, but it is an ellipse. Okay, so what we need to do is first we need to make the constant term on the right to become 1. So what am I going to do for part C is I will start with this 4x squared plus 9y squared equals to 16. So I'm going to divide throughout by 16. Okay, so when I divide throughout by 16, right, so I have a x squared over 4 plus 9y squared over 4, over 16 is equals to 1. Right, so my first goal is done. Right, my first goal is done to make the right hand side 1. Okay, next I will need to make it such that I have a squared b squared. The thing is the numerator coefficient in the numerator is 1. So what am I going to do is, now I think some of you may miss this. So what am I going to do is, now here for this term the numerator is already 1, so I'm satisfied. So for the second term, the numerator has a 9. So what do I need to do to get rid of the 9? I need to divide by 9, but not divide throughout. Divide at the term, because I don't want to affect the other terms. So only on the term, if I divide by 9 on top, how to balance back? I need to divide by 9 at the bottom. So that when I divide, is only here. I do not disturb this and this. You get what I mean? So what I have at the end of the day would be, I have a x squared over 4, which is a 2 square, plus y, okay wait, I think I will do this, x squared over 4 plus y squared over 16 over 9. Okay, equals to 1. And last but not least, I can tidy this up, x squared over 2 square plus y squared over 4 over 3 square. I will need to write it in the form of a b square, right? So you know, so you can see what I mean by this. Okay. Okay. So last but not least, to sketch. Okay. So the thing is the a, this a, the value of a over here, this will give me the horizontal length. Okay. So means that here must be 2, here must be negative 2. Okay, it will give me the horizontal length. Now, and then this value of the b over here will give me the vertical length, 4 over 3. So over here, I will maybe have a 4 over 3 on top. I would have a negative 4 over 3 at the bottom. Okay, so let me rearrange a bit. Okay, so what do we do now is that now we are ready to draw the ellipse, so the oval shape. Okay, so I'm going to try and draw. Okay, so roughly I have this shape as the oval shape. And yeah, so we get this oval shape, and yeah, this would be the end of Test Yourself in page 13. Okay, last but not least, we have a Test Yourself in page 15 to come about. Okay, so the next Test Yourself is in page 15. Alright, and we'll try to recognize what is this equation. Okay, so is this a circle? Is this an ellipse? Actually, no. If you notice, right, if you take note, the x square and the y square, right, there is a minus in between them. Same thing also, I have a x square, y square, right? There's actually a minus between them. So actually this tells me that this is actually a hyperbola, right? So let's write out what is the general form of the hyperbola. So the hyperbola would be same like ellipse, so x square over a square minus y square over b square equals to 1. So over here the 1 is also very important. Okay, in the same way also I may have y square over b square minus x square over a square equals to 1. So I may have this also. Okay, so I just need to be very sensitive about these two cases. Okay, so let's look at the first one for A. Now we need to make this, transform this into either this or this form, correct? So I'm going to have a x square and y square on the left, and I need the constant term to be on the right. So let's shift the 18 to the right hand side. Okay, equals to 18. I can divide everything by 3 first, so that I can see it like better. Divide by 3. Okay, now the next thing that we're going to do is I am going to divide everything by 6, because I need to make the right hand side 1. So over here I have a x square over 6 minus y square over 3. This is equals to 1. Then we write it out in a square form. So over here I have a x square over root 6 square minus y square over root 3 square. So this is equals to 1. So now with this in mind, right, the asymptotes. Okay, the asymptotes are going to be okay, so in general the asymptotes are y equals to plus minus b over a x. Okay, b over ax. So over here we are going to take the value of y, so this is going to be y equals to plus minus the value of b over the value of a x. Okay, so all together let's combine. So root 3 and root 6, this would be root 3 over 6, and I'm going to simplify this to just 1 over root 2, is just half. Okay, so I have root 3 over 6, right? Then this 1 on the inside becomes a half. Then when you apply square root to each of them, so I have a 1 over root 2x. For this question, we don't need to worry about don't have to worry about rationalization first. Okay, the main important thing is to get the equation out for asymptote. Okay, so don't worry about that first. So next, last but not least, we sketch. So in general, alright, the first few things that we need to sketch are the number 1 is axis. Number 2 that we're going to sketch is the asymptote. So that we really need to sketch the asymptotes first. So over here, right, the positive version would be this, positive 1 over root 2x, and the negative asymptote would be negative 1 over root 2x over here, right, if you can see, right? Okay, so now what we're going to do is okay, let me pull myself down. Okay, so what we're going to do is now we are going to use the calculator to check where is the graph. Okay, so the calculator tells us it's going to be over here, right? So we sketch it properly to get something like this. Okay, something like this. Now then I'm going to mark out the x-intercepts. So where are the x-intercepts? They are when y equals to 0, or actually you don't need to think so far, you just need to look at this number alone. Okay, so the x-intercept will be following this number for x. So this point, this would be negative root 6, this would be just root 6. Okay, so there we go, the graph for the hyperbola for A. Okay, so let's come back to part B. So part B, we have an x square minus 4y square equals to negative 4. So over here, right, because if you notice, we need to make the right hand side 1, correct? So what am I going to do is I'm going to divide throughout by negative 4. So over here, when I divide by negative 4, so it will be negative x squared over 4. I have a plus y squared over 1 is equals to positive 1. Then after rearranging again, y squared over 1 minus x squared over 2 squared is going to give me 1. Okay, so this is the equation of hyperbola that I have. Right, so immediately I can actually write out my asymptote. So the equation of the asymptote is going to be plus minus b over ax, right? So y equals to plus minus b over a. B is 1, a is 2. right? So it is the y number over the x number. Okay, so 1 over 2x for the asymptotes. Okay, so after that we will sketch the axis and the asymptotes and label our asymptote first. So this is the positive asymptote, this is the negative asymptote over here. Alright, so one check in your calculator, we don't have to plot, we just need to look at the shape in the calculator, tells us that it's going to be like this. Okay, so let's plot this nicely. Okay, so last but not least, right, after we sketch, now take note, this distance, okay, so this distance over here and this distance over here should be equal, okay, you cannot change it too much, it has to be symmetrical. Okay, so what are the coordinates over there? We follow because this is on the y-axis, we follow the number below the y square. So this number over here would be a positive 1, this number over here will be a negative 1. Alright, so means that we have a hyperbola, vertical hyperbola over here. Okay, alright, so for the very last test yourself in page 21. Okay, so we are sketching the curves defined by each of the following pairs. So we have 3 curves to look at, and we're going to sketch them down here. Now first, let's take a look at number 1. So how do we sketch this curve? Now if you press so for parametric curve, unfortunately we really have to use our graphing calculator to figure out. Okay, so once we key in, we actually see something like this. But the problem is, I don't know whether is it an ellipse or parabola, because if it's an ellipse, then the tangent over here must be horizontal, right? So this means that the graph is like this, it must be horizontal and start to come back, right? But if it's a parabola, then it's just outwards, go outwards. Okay, so we just need to see which one does it belong to. Does it belong to an ellipse or does it belong to a parabola, right? Does it go outwards? Okay, so for that to happen, we will need to monitor the equation itself. Okay, so now first let's see what happened, or let's try to figure out the bounds. Okay, figure out the boundary algebraically. So over here, I'm going to start with 4 cos square x, right? So first, cos x would be between -1 to 1. So when I square it, all the negative number will become positive. So the smallest value will become 0. Okay, then multiply by 4, multiply by 4, multiply by 4. So over here, this will become x. So x will be between 0 and 4. Okay, so the graph will be between 0 and 4. Now let's test for y as well. So same thing, sine x will be between -1 to 1. Okay, so when you multiply by 2, it will be between -2 and then less than or equal to 2 sine x, less than or equals to 2. So multiply throughout by 2, and then we get our bounds for y. So meaning the maximum value for y is 2, the minimum value of y is going to be -2. Alright, so let's finally check out and see whether is this an ellipse or whether is this a parabola. Right, so for this one, we're going to make use of the identity, right? So using the identity, sine square plus cos square, right? So this equals to 1. So over here, I already have sine theta. So over here, my sine theta would be y over 2. Correct? So sub in. So sine square theta would be y over 2 square. Cos square theta would be just x over 4. So plus x over 4 equals to 1. Okay, so let's do a bit more fine tuning, and then we can see that actually this is y square over 4 plus x over 4 equals to 1. Then multiply by 4. Now you see that actually y has a square, x doesn't really have a square. So what this means is that this becomes a parabola. So it's something like y equals to 1 minus x squared. So it's the same but reverse. Okay, same thing but reverse your alphabets or reverse the unknowns. Okay, so means this is going to be a parabola, and maximum would be negative 2 to -2. Then the x would be between 0 to 4. So means this is going to be a parabola. So I try not to, I try to have something like this, try to have something like this. So my graph would be something like this. Okay, instead of an ellipse where I would try to aim to make it a bit more horizontal for this part, you know, like that. Yeah. Okay. Okay, for part 2, we don't really need to find the range because we usually only find the range for uh we only find the range for what for for sine and cosine, right? For this case over here, right, we just need to take note because of this t, right? Because of this t, right? So over here t cannot be 0. So when we plot, make sure that the t cannot be 0. Okay? Now, and then at the same time also, let's try to find out what is the original equation by making t the subject. So over here on the left hand side I have a t equals to x over 3. Then here I will have a t equals to 3 over y. So 1 equals to 2. So over 3 would be equals to 3 over y. Multiply, I will have xy equals to 9, or y equals to 9 over x. So this tells me that it's a rectangular hyperbola. So it's like what we did in E math. So the graph is very simple. Okay, the graph would be something like this. Very easy one. Okay, so the graph would be like this. The graph would be like this. Okay, yeah, there's no intercepts. Okay, last but not least, we have this one over here. We have a x equals to sine theta over 2, y equals to 3 cos theta. Okay, so in the same way, let's try to find out the range of our numbers. So first and foremost, I will have a sine theta in between -1 to 1. So divide by 2, so I have a negative half less than sine theta over 2 less than half. So this tells me that x would be between negative half and half. Next, for y, first I'm going to start with cosine. So cosine would be between -1 and 1, multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3. So over here, my y will be between 3 and -3. So this tells me that I will get this part ready already. Now, next, let's find out the original form of the graph. So over here, I will have a sine theta will be equals to 2x, right? And over here, cos theta will be equals to y over 3, correct? So from, okay, the basic identity, so sine square theta plus cos square theta equals to 1. Okay, so sine square theta will give me 2x square. Cos square theta will give me a y over 3 whole thing square. So altogether, I will have a 4x square plus y square over 9 is equals to 1. So if you notice, this is a x square plus y square graph. X square plus y square graph give me a, and the coefficient are different, right? It gives me an ellipse. And let's check, the right hand side is already 1, so we are settled. We just need to massage this 4 to give us the x square over something. So what am I going to do is I will divide by 4 on the numerator and divide by 4 at the denominator. Okay, so what I have at the end would be just x squared over 1 over 4. Okay, or if I want to write it, it will be 1 over 2 square. Then over here, this would be my 3 square, and then this would be 1. Okay, so this ellipse, right? Now, we have to take note, yeah, so for this ellipse, okay, for this ellipse, so sorry, I missed out I missed out something for this part. Okay, I missed out something for this test. Okay, because they gave us a bound. They gave us 0, theta, and pi. Okay, so between 0, theta, and pi, right, if you look at the graph, so the graph will look something like this over here, correct? Between 0, theta, and pi, and the remaining will be over here. So means this would be when you apply sine, right, it will be between 0 to 1. If you see from here, it will be between 0 to 1. Can you see? Okay, so this graph, right, the y values are between 0 to 1. Okay, then now we divide by 2. So over here, we have something like this. So my x will be between 0 and half. Okay, the y no change. I think y is fine. Because between 0 to pi, right, cosine will give me between -1 to 1. Okay, alright. So how do we sketch this? So this is an ellipse, and then let's check. The x is half, the y is going to be 3. Okay, I will just do this. Okay, okay, let's exaggerate a bit, and then let's do 3 over here. Let's do 3. It's not to scale, but we try lah. Okay, so the graph would be something like this, like this, like this. Okay. Okay, cannot. Yeah, must be smooth. Cannot like. Yeah. Okay, so this is my ellipse for test yourself. The last test yourself and question 3. Okay, I so sorry about earlier. We also need to check this. Let's check for this range and apply this range when you do your sine and cosine. Okay, so for this one, so this ends the all the test yourself questions. So I hope this helps you to understand what's going on. Okay, all right. So finally, let's have a good weekend ahead and hope you have good time consolidating all your knowledge. Okay, bye bye.